Hi, my name is Tim Adams. I'm one of the rep experts here at Schaeffler. What we'd like to do in today's video is share some information with you on the setup for the VAG 1.9 and 2 litre TDI timing belt tensioner stud replacements. This is a common engine. It's slightly awkward in as much that it has an aluminium cylinder head with a steel stud mounting for this common type of timing belt tensioner. It's critical that this stud is checked when it's removed for any damage or any aluminium deposits from the head, and also that the thread is in good condition once you've removed it. If you put a new stud into the old thread, if it's damaged, it will just work itself loose and the stud will snap off. So as with any engine, before you start a timing belt change, we would like it at ambient temperature, that's room temperature, 18 to 20 degrees. To double check the temperature of your engine, these thermo lasers are coming down to around £13–14 in price now. It's great just to check that engine so you know it's at the right temperature before you start to change the components. We always recommend best practice for any of the jobs that we do. The stud removal and replacement, we would use a proper tool. We're using today the Sykes unit. You have two different types of stud which are used on these range of engines. We have an M8 fine thread and an M8 M10 coarse thread. Both potentially can shear off if we don't show some consideration when we're changing them. Okay, so let's start by taking the stud out. On this tool, we like this because you can go anywhere on the thread without any damage, and it has good purchase on the thread as you try to remove it. So we pop the stud tool on, we tighten up the second nut, and then we can remove the stud. Once we have it loose, we'll pop that off. We'll take the stud out, and we're looking all the time for any deposits that have come from the head that may be in the threads on the stud. As we've said, the hole is really important. In fact, it's critical. So if you have one of these endoscopes, you can have a look inside, see how the thread looks, or just a magnifying glass and a torch. But what you don't want is any aluminium deposits in there that are going to back up and not let your stud go in far enough. Okay, so when we put the new stud in, we use the second part of the tool, which has an Allen key in the end with a ball bearing. We pop that onto the stud. We screw the stud into the head. Now this is where we need to torque up the stud. It's critical that this stud is torqued. It's around 15 Newton meters. We're not doing it on this head because we know we have some damage to the stud. Once that's done to 15 Newton meters, we're now ready to go on to the next stage of the setup. So we'll pop off our tool. And then we introduce you to a tool that we've developed here at Schaeffler, which we can use to assist you with the setup of the stud, to make sure you have it in far enough basically. So this stud has a machined end where it's recessed, so if you have the M8, M10 stud which is too far out, the sleeve will go over it. And the idea is once this tool goes over and goes flush to the cylinder head, if anything protrudes the end of the tool, then the stud isn't in far enough. So let's just look on this unit here. You can feel, you don't even have to look, and straight away we can tell that this stud is not in far enough. It's an indication of where you are. If the stud hole is damaged, you then have to use either a time cert kit, or you have to use have it helicoiled, and there's a bit more work involved. So that's the first part. It gives you an indication where you need to be. The second part is this block. And the idea of the block is if you have had to repair the thread, then you can pop the block on and use it as a square and check the squareness of the tool. And as you can see here, we have a gap between the tool, and if I turn it to the side, you'll see I also have a gap at the bottom. So although the stud may be in, and you may have it in far enough using your other part of the tool, this is really important that it is perfectly straight. So I'd just like to discuss now what happens if the stud is actually sticking out too far. What will happen is you have a thing called cyclic stress. If you were to take a paper clip and keep bending it till it broke, that effectively is cyclic stress. With the firing pulses of your engine coming around and rocking your tensioner, effectively what happens to your stud is this effect. The constant vibration will keep bending that stud until it shears off. When the stud is in correctly and the tensioner is torqued and the degrees are applied, that stud now has good purchase within the head, it's clamped correctly, and you shouldn't have any issues with cyclic stress damaging the stud. Even if you've tightened up the tensioner, if it's sticking out too far, it doesn't have enough purchase within the head, and it will just carry on cycling until it breaks off. So once we have the stud in, we're happy it's in deep enough, we're happy the thread is okay, we've checked it for squareness, we then put our tensioner on, and this must be torqued up as well. It's 20 Newton meters for the torque of the nut, and then you must apply 45 degrees. The 45 degrees in effect is trying to stretch the stud so it then wants to go back to its original size, and only with the 20 Newton meters and the 45 degrees will that be held securely, and you shouldn't have any issues with it.